A source alphabet consists of n symbols with the probability of the first two symbols being the same. A source encoder increases the probability of first symbol by a small amount of epsilon and decreases the second by epsilon. After encoding, the entropy of the source is A increases, B remains the same, C increases only if n equal to 2, D decreases. This is a question based on conceptual understanding. Instead of remembering what is the formula of entropy, you should understand what entropy actually gives us. See here, there are n symbols. There are n symbols with probability of the first two symbols being the same. So the source encoder, what it does is, the probability of the first symbol to be sent is increased now by a small amount epsilon, and for the second one it is decreased. See, let us say there are symbols like A, B, C, D, so on are to be transmitted. Probability of sending A is some x. Probability of sending A, transmitting is x. Let us say x, okay. And probability of B was also x only initially. But what did the source encoder do? Source encoder did that probability of A sending A is increased. It means many times we are going to send A. Sending A is more likely than sending B, given x minus epsilon, probability of B. Okay, now he is asking how the entropy is affected. What is entropy? Entropy is actually the average amount of information that we get. See, for example, if I say sun rises in the east, how much information do you get? There is no new information, that you already know. But when I say sun rises in the west, then you get a nice surprise because it never happens. The probability of happening of this event, that is sun rises in the west, is very low. When I say this statement, you look with a shock because the probability of this happening is very low. So you get more information. Therefore, information is inversely proportional to probability of its happening. Okay, if the probability of happening is very low, then you get more information. For example, if I say lion killed a rat, there is no information. It's obvious. But if I say a rat killed a lion, then you get a lot of information because the probability of this happening is very low. Okay, the same thing can be applied here. Entropy is what? The average information we get. Probability of A and probability of B are same before, means x and x. So we cannot say with a guarantee that we are going to receive x, A or B. But in the second case, since the probability of A is large than the probability of B, mostly we can say that A we are going to receive. So we are going to receive A more. So we can say that the amount of information is decreased. Average amount of information is decreased because we will mostly see A. Okay, therefore the entropy is decreased. Here when you are increasing the probabilities, this can be applied for a head or tail. See, a coin has heads and tails with 1/2 probability. Then we cannot expect anything. But if you are given that heads will fall with 75% and tails with 25%, you will obviously say heads because mostly 75% chances are there for head. So there is no new information is less in this case. But in 0.5 probability case, you get a large information. You wait for the result. But in 75%, 25% case, you will not be very interested in the output because mostly you know that it will be the heads, that is 75% case. Therefore, it is decreased. So D is the option.